welcome students. Hope you're all doing good and staying safe. So before we move on to today's class, let us just have a recap of what we learned in the previous class, okay? So first, we looked into the introduction to algebra. In introduction to algebra, we saw what is algebra, the various uses of algebra, the patterns, and understanding the operations on variables. And at last we looked into what is a variable, okay, and then we solved few problems based on these topics. In today's class we'll be learning about the framing algebraic statements. So in framing algebraic statements we'll be looking into the conversion of algebraic statements to verbal statements, conversion of verbal statements to algebraic statements, solving unknown through examples, and we'll be solving few problems, okay. So first we'll be looking into framing algebraic statements. Consider the following situation, students. Say you went to a birthday party and they were serving burgers, but two people did not turn up, meaning that there were two burgers left on the plate. Only three burgers were eaten, okay, so there are three empty plates. Now the question is, how many burgers were there at the start, okay? So we can find the number of burgers at the start by framing the algebraic statements, okay? So first, the x over here represents the number of burgers at the start, okay? Since we do not know how many burgers were there at the start, we are going to represent it as x, okay? So from the total number of burgers, 3 has been eaten up, okay? So you're going to subtract 3 from x, that is 3 burgers were eaten, okay? So that is equal to 2. 2 represents the number of burgers left uneaten, okay? So here you're going to find out the number of burgers at the start. So in order to find the number of burgers at the start, you're going to bring the minus 3 to the right hand side, okay? That is, we are going to keep all the variables on the left hand side and we are going to keep all the numbers on the right hand side, okay? The one which we are going to find only, we are going to keep it on the left hand side. So when you bring minus 3 to the right hand side, you will be getting x is equal to 2 plus 3, okay? So minus 3, when it comes to the right hand side, it becomes plus 3. So when you add 2 and 3, the answer you get is 5, okay? So therefore the number of burgers at the start is 5. So this is how you frame the algebraic statements. Got it, students? In framing the algebraic statements, we'll be looking into the conversion of algebraic statements to verbal statements and then conversion of verbal statements to algebraic statements, okay? So first we'll be looking into converting algebraic statements to verbal statements. So the left hand side will be the algebraic statements and the right hand side will be the verbal statements, okay? So the first one is m plus 14. So in algebraic statements, the statements will be represented as a variable and a number, okay? What is a variable? Whose value is not known is called as a variable, okay? So here m is a variable and 14 is a number. So in algebraic statement, the statements will be represented like this only, okay? So here m is 14. So in the verbal statement, you will be writing it as 14 more than m. The plus over here indicates that more than, okay? So in verbal statement, it will be represented as 14 more than m. And the next one is x minus 6. So over here, x is reduced by 6, that is, it is subtracted, okay? So we'll be writing it as the variable x is reduced by 6. Subtraction is represented as reduced by and plus is represented as more than, okay? And the third one is 3y or 3 multiplied by y. So multiplication over here is represented as product in verbal statements. So you will be writing it as product of 3 and y. So the fourth one is 5 divided by z or 5 by z. So here the division symbol is represented as divided by in verbal statement. So you will be writing it as 5 divided by z, okay? And the fifth algebraic statement is 2p minus 5. Here you can see that there is a product of 2 and p in the first place. Okay, so from that 5 is being subtracted, so you will be writing it as 5 less 2 times of p. Okay, the product 2 and p is written as 2 times of p. Okay, so here in verbal statement the algebraic statement will be written as 5 is less to 2 times of the variable p. Got it, students? Now we'll be moving to the conversion of verbal statements to the algebraic statements. It is just the reciprocal, okay? So first we'll be writing the verbal statements on the left hand side, and next we'll be writing the algebraic statements on the right hand side, okay? So the first one is x is increased by 21. What does it mean? X is being increased. Increased means it is being added. Okay, so we'll be writing it as x plus 21 in the algebraic statement. Okay, so in verbal statements it will be written as wordings, whereas in algebraic statements it will be represented as a variable and a number. Okay, and the second one is 7 is being taken away from 8. So taken away means it is being subtracted. Okay, so 7 is being subtracted from a. So you'll be writing the algebraic statement as a minus 7. Okay. Third one is twice p. Twice p means it is a product of 2 times of p. So you'll be writing it as 2p in the algebraic statement. And the fourth one is 10 divided by n. So in algebraic statement you will be writing it as 10 divided by m. Okay. So the last one is the product of 7 and y is divided by 2. So the product of 7 and y, right? The product of 7 and y first. Okay, so what is the product of 7 and y? It is 7y. Okay, so the 7y is being divided by 2. So you'll be writing it as 7y divided by 2. Got it, students? This is the difference between the verbal statement and the algebraic statement. So in verbal statement, you'll be writing it in wordings, whereas in algebraic statement, you'll be representing it in variables and numbers, okay? You'll be using the 4 basic operations. So what are the 4 basic operations? It is the addition, subtraction, multiplication and division, okay? So you'll be representing the algebraic statement using the variables, numbers and the basic operations. Got it, students? So next, we'll be looking into solving unknowns through examples. Okay, so first let us fill up the empty boxes. So the first question is unknown plus 3 is equal to 8. Okay, so that box represents the unknown number. So when you add the unknown number with 3, you'll be getting 8. In order to find the unknown number, you're going to take the plus 3 to the right hand side. Okay, so when you take the plus 3 to the right hand side, you'll be getting 8 minus 3. Okay, so the plus 3, when it comes to the right hand side, it will become minus 3. Okay, so when you subtract 3 from 8, you will be getting the answer 5. Got it, students? In order to find the unknown number, you will be taking the plus 3 to the right hand side. So plus 3, when it goes to the right hand side, it becomes minus 3. So when you subtract 3 from 8, you will be getting the answer 5. Okay. So the second sum is 2 plus unknown value is equal to 9. So when you add 2 to the unknown number, you will be getting the answer 9. So in order to find the unknown number, you are going to take the 2 to the right hand side. Okay, so when you take the plus 2 to the right hand side, you will be getting 9 minus 2. So when you subtract 2 from 9, you will be getting 7. Understood, students? In order to find the unknown number, you are going to take the plus 2 to the right hand side. Okay, so when you take the plus 2 to the right hand side, it becomes minus 2. When you subtract 2 from 9, you will be getting the answer 7. Got it, students? The third one is 11 minus 5 is equal to a unknown number. This one is a direct question and you're going to subtract the value 5 from 11. So the answer you'll be getting is 6. Now we'll move on to the problems. Okay, I am going to solve the exercise number 2.2 So I'll be solving the questions from 3 to 7. Okay. So the third question is express the following verbal statements to algebraic statements. So the first question is 3 is added to 100. So it is very simple that you will be adding t plus 100. Okay, and the second one is 4 times of q. So what does 4 times of q mean? It is a product, so you'll be writing it as 4q. So the third question is 8 is reduced by y. What does reduced mean? You're going to subtract, so you'll be writing it as 8 minus y. Okay. So the fourth question is 56 is added to 2 times x. So what does 2 times x means? It is the product. So you're going to multiply 2 and x. So you'll be writing it as 2x. So added means you're going to do addition. Okay, so 56 is added to 2x. So you'll be writing it as 56 plus 2x. And the last one is 4 less to 9 times of y. So 9 times of y means again you're going to write the product. So it will be represented as 9y. Okay, and 4 less to 9 times. So you'll be writing it as 9y minus 4. Got it, students? And next we'll move on to the fourth sum. Express the following algebraic statements to verbal statements. Okay, so the first one is x divided by 3. So in verbal statements, you'll be writing it as x divided by 3. Okay, so verbal statements means you're going to write it by wordings. The second one is 5n minus 12. So from this you can see that 5n represents it is 5 times of n. Okay, so 12 is being subtracted from 5n. So you'll be writing it as 12 less to 5 times of n. Okay, and the third one is 11 plus 10x. Similarly, here 10x means product of 10 and x, that is 10 times of x. Okay, so 11 is being added to 10 times of x. So 11 added to 10 times x. And the fourth question is 70s. Here this is the product of 70 and yes. Okay, next we'll move to the fifth sum. The teacher asked two students to write the algebraic statement for the verbal statement 8 more than a number. So the first student, Vetri, wrote it as 8 plus x, but Maran wrote it as 8x. Okay, so who gave the correct answer? So let the number be x. Okay, so let the unknown number be x. And what is given in the question? 8 more than a number. So what does more than mean? You're going to add. Okay, so the answer is 8 plus 6. So from the question given, Vetri's answer only is correct. Now we'll move to the sixth sum. Answer the following questions. So the first one is, if n takes the value 3, find the value of n plus 10. So what is the value of n? It is 3. Okay, now you're going to find the value of n plus 10. So in the place of n, you will be substituting the value 3. Okay, so when you add 3 plus 10, the answer you get will be 13. So therefore, n plus 10 is equal to 13. Got it, students? It's very simple. You're just going to substitute the value of n in the question. Okay, so by adding n plus 10, you'll be getting 13. That is 3 plus 10 is equal to 13. Okay, we'll move to the second sum. If g is equal to 300, what is the value of g minus 1 and g plus 1? So what is the value of g given in the question? It is equal to 300. Okay. So first you're going to find the value of g minus 1. So the value of g is 300. So when you subtract 1 from 300, the answer you get is 299. Okay. So the value of g minus 1 is equal to 299. Similarly, you're going to find the value of g plus 1. So what is the value of g plus 1? You're going to write 300 in the place of g, and then you're going to add 1 to 300. So the answer you'll be getting is 301. So the value for g plus 1 is 301. Okay. Got it, students? You're just going to substitute the value of g in the question. So when you substitute the value of g, that is 300 in the question, first you'll be subtracting 1 from 300. So the answer you'll be getting is 299. Similarly, when you substitute the value g, that is 300, you're going to add 1 to 300. So you'll be getting 301. Okay, so the answer for g plus 1 is equal to 301. We'll move to the third sum. What is the value of s if 2s minus 6 gives 30? So in this case, you are going to find the value of s. So what is given in the question? 2s minus 6 is equal to 30. Okay, you're going to find the value of s. So you are going to bring the minus 6 to the right hand side. So when you bring the minus 6 to the right hand side, you will be getting plus 6. Okay, so you're going to add 30 and 6. So the answer you get is 36. So in the left hand side, you could see that there is 2s. We are going to find the value of yes. So we do not need the number 2. So it is in the product. You could see that it is a product of 2 and s. So since it is in product, when you bring the product to the right hand side, it becomes division. Okay. So the value of s is equal to 36 by 2 is equal to 18. That is when you divide 36 by 2, you will be getting 18. Got it, students? It's very simple actually. You are going to find the value of s in this question. Okay, so what is given in the question? It is 2s minus 6 is equal to 30. So we are supposed to find the value of x. So when you bring the minus 6 to the right hand side, you will be getting the value 36. So what is the reason for bringing minus 6 to the right hand side is you're going to have the variables on the left hand side and you're going to have all the numbers on the right hand side. Okay, so I am going to bring the minus 6 to the right hand side. So when minus 6 comes to the right hand side, you'll be getting plus 6. So when you add 30 and 6, you'll be getting 36. So from the left hand side, you could observe that there is 2 yes. Okay, so it is in the product form, that is 2 multiplied by x. So when 2 multiplied comes to the right hand side, it becomes division. Okay, so you will be dividing 36 by 2. So the answer you get is 18. Understood, students? And we'll move to the last sum. Complete the table and find the value of k for which k divided by 3 gives 5. Okay, so this is the tabulation. They have given the values of k and you are going to find the value of k divided by 3. Okay, so you are supposed to find the value of k divided by 3. So the first one is k is equal to 9. Now we are going to find the value of k divided by 3. Okay. So in the place of k, you will be substituting the value 9. Okay. So when you divide 9 by 3, the answer you get is 3. Okay. And the second one is k is equal to 12. So you're going to find the value of k divided by 3. In the place of k, you will be substituting the value 12. So when you divide 12 by 3, the answer you get is 4. Okay. And the third one is k is equal to 15. Similarly, in the place of k, you're going to substitute the value 15. So the answer you get is 5. And the last one is k is equal to 18. And in the place of k, you're going to substitute the value 18. So when you divide 18 by 3, you get 6. Okay, so in the tabular column, you will be filling the values of k by 3 as for 9, you will be getting 3. And for 12, you'll be getting 4. And for 15, you'll be getting 5. And for 18, you'll be getting 6. Got it, students? So that's it for today's class. Okay. Now I'll do a recap of what we learned in today's class. Okay. So first, we looked into the framing algebraic statements. So with an example, we saw how do we frame the algebraic statements. Okay. And in framing algebraic statement, we saw how to convert algebraic statements to verbal statements and how to convert verbal statements to algebraic statements. Okay. So first we looked into converting algebraic statements to verbal statements. So we saw examples. So the first one is m plus 14. So you'll be writing it as 14 more than m. Okay. And the second one is x minus 6. You will be writing it as x is reduced by 6. And the third one is 3y you'll be writing it as product of 3 and y, okay? And the fourth one is 5 divided by z, and in verbal statement you'll be writing it as 5 divided z, okay? And 2p minus 5, you'll be writing it as 5 less to 2 times of p. So in verbal statement, you'll be writing it in wordings, whereas in algebraic statement, you'll be representing it using variables, numbers, and the 4 basics operation. And next we moved on to the conversion of verbal statements to algebraic statements. So in verbal statements, the first one is x is increased by 21. We'll be writing it as increased means you're going to just add, okay? So you'll be writing it as x plus 21. And the second one is 7 is taken away from a, that is, it is being subtracted. So you'll be writing it as a minus 7. And the third one is twice of p. So twice means it is product. So you'll be writing it as 2p. And the fourth one is 10 divided by m. So you'll be writing it as 10 divided by m in algebraic statements. Okay, that is, you'll be using the basic symbol for addition. And the fourth one is the product of 7 and y is divided by 2. So first you're going to find the product of 7 and y, that is, you're going to represent it as 7y, and it is being divided by 2. Okay. And next we moved on to the solving unknowns through examples. So first we saw how to fill up the empty boxes. Okay, in order to find the unknown value, you're going to take the known value to the right hand side. Okay, so that is in the first question. In order to find the unknown value, you're going to take the plus 3 to the right hand side. That is 8 minus 3, you will be getting it as 5. And in the second question, 2 plus unknown number is equal to 9. Similarly, when you take the 2 to the right hand side, you will be getting minus 2, and the answer you get is 7. Okay, that is, when you subtract 2 from 9, you will be getting 7. And the third one is a direct question, so you're going to subtract 5 from 11, and the answer you will be getting is 6. And next we saw the book bag problems. Okay, that's it, students. So now it's time for question and answer. So the first one is, you're going to convert the following statements from algebraic to verbal. Okay, so the first one is 2p minus 5. So how do you write this? Yes, very good. It is 5 less to 2 times p. And so the second one is x minus 16. So how do you write this in verbal statement? Yes, it is x is reduced by 16. Very good. The second one is, you're going to convert the following statements from verbal to algebraic. Okay. The first one is 7 is taken away from a. So how do you represent this in algebraic? Excellent. It is a minus 7. Yes. And the second one is, the product of 7 and y is divided by 2. So you'll be writing it as 7y divided by 2. Very good. So I have attached the worksheets for you. Kindly solve it in your rough notebook. Thank you, students.